Suppose you are in India under a network. Let's call that network as Geo. So from India, Geo, it has lot of hosts, and every host has lot of processes. Let's take a process. So this is a network host process. So from this host, from this process, you are trying to access www.amazon.com. Let's suppose this is the network of the Amazon. So to get your resource, after hitting the network, from the network you need to hit the host and the process. For all this process to make it happen, you need IP address. IP address is divided into two parts: network ID, host ID. So this will be network ID and this will be host ID. In number systems, you have unary, which has a single digit 0, binary, which has 2 digits 0, 1, and octa, which has 8 digits, which is from 0 to 7, and decimal, which is 0 to 9, and hexa, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and for 10 it is represented by alphabet A, for 11 it's B, for 12 C, 13 it's D, 14 E, and 15 is F. So in unary, to count the numbers, for 1 it is 0, for 2 it is 0, 0, for 3 it is 0, 0, 0, for 4 it is 0, 0, 0, 0. So this was the way unary system was being used. So you can check on all these number systems. So before going through this further video, so for now let me talk about the binary system. So guys, in binary system you have 2 digits, which is 0, 1. Now if you take 1 bit, so 1 bit you have 0 or 1. Now if you take 2 bits, you have 0, 0, 0, 1, 1, 0, 1, 1. And similarly, if you take 3 bits, you have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So if you observe, for 1 bit you have 2 combinations, so which is 2 power 1. For 2 bits you have 4 combination, which is 2 power 2. For 3 bit you have 8 combinations, which is 2 power 3. So if you can observe, for n bits you can generate 2 power n combinations. And you know that for 2 power 10 it's K, for 2 power 20 it's mega, 2 power 30 it's giga, 2 power 40 it's tera. By selecting K bits, you can divide the whole IP address into 2 power K parts. Suppose there are n bits in the IP address, so you have total 2 power n IP addresses. Now by this, so total is 2 power K parts for 2 power n IP addresses. Then every part has 2 power n minus k. 2 power k parts constitute 2 power n IP addresses, then every part is 2 power n minus k. Initially, at 1980s, the IP address we divided into 8 bits for network ID and 24 bits for host ID. So which means that we had 2 power 8 networks, which is 256, and 2 power 24 host IDs, which is about nearly 16 million. In Bangalore, maybe just Bangalore itself is having 256 networks, so it's really not scalable. So to make the IP address scalable, later we went on to classful approach. So let's discuss what is classful approach. To make the IP address really scalable, we went for classful approach. So in this classful approach, if we select the first bit, we can divide the IP address into 2 parts. So all the first part will have 0 at the beginning and second part will have 1s in the beginning. So this will be 2 power 31 and this will be 2 power 31. So this IP address is of 32 bits. And now if we take this here you have the first bit as 1, and if you also select the second bit, then you divide this IP address into 2 parts. Since the first bit is already fixed, you are just selecting the second bit, so this part will have all the 1 zeros and this part will have all the 1 1s. So this will be 2 power 30, 2 power 30. And from here, now we have first 2 bits is fixed, and now we want to fix the third bit. So if you fix the third bit, then this IP address will be divided into 2 parts, and this will be 2 power 29 and this will be 2 power 29. 2 power 30 divided by 2 will be 2 power 29 and 2 power 29, and this will have all 110 at the beginning, and this will have all the 111 in the beginning. Now take this here. You have already 1 1 1, and if you fix the fourth bit also, then this will be divided into 2 parts. This will be 2 power 28, this will be 2 power 28, and this will have 1110 and 1110, so on, and this will have all 1111 1111 1111. So here we call this as class A, we call this as class B, we call this as class C, we call this as class D, and this as class E. So for class A, the first bit is fixed, which is 0. For class B, the first 2 bits are fixed, which is 10. For class C, first 3 bits are fixed, which is 110. For class D, first 4 bits are fixed, which is 1110, and for class E first 4 bits are fixed, which is all ones. Now if you see here, the IP address, if you select k bits, then you have 2 power n minus k host IDs. So this will be network, this will be host. By the same way, if you try to calculate the range of class A, class B, class C, class D, for class A, so guys, if you see here, for class A the starting bit is 0, for class B the starting bit is 10, for class C the starting bit is 110, for class D it is 1110, for class E it is 4 ones. And to represent the IP address, you can represent it using binary system with all 1 zeros, or you can represent it as a decimal number, or the famous notation to represent the IP address is dotted notation. So in dotted notation, you divide the IP address into 4 blocks, and each block has 8 bits, and all these are represented as A dot, B dot, C dot, D. And now let's see what is the range of the class A. In class A, network ID is given 8 bits and host ID is given 24 bits. So by this, since the first bit is fixed, then you have all the things from 1, 2, 3, 4, 6, then you have from 0 to the last one is all ones. This will be 127. So how is it 127? Since you have 7 ones, it will be 2 power 7 minus 1, which is 128 minus 1, that is 127. So the range of the class A is 0 to 127. Now for class B, let's see what is the range. For class B, the IP address is divided into first 16 bits is given for network ID and the rest 16 bits is given for host ID. So now for this, for class B to calculate the range, first one are 1, 0, and then you have all zeros. So total 8 bits and you have all the zeros, and this will be 128. And similarly, the last one will be, since first 2 bits are fixed, 10, and the last one will be 111, 111. This will be 191. And now for the first octal, the range is 128 to 191. So what are the total number of IP address that can be formed for? So what is the total number of network IDs that can be found for class B? So for class B, the total number of network IDs are 128 to 197. It is 64. And since we said it is 16 bits, since the network ID is 16 bits, 8 and 8, and for first 8 bits you have 64 combinations, and for next 8 bits you have 2 power 8, 256 combinations. So 64 into 256, it's approximately 16k. So there are total number of 16k networks for class B. And what is the host? It is 2 power 16. So similarly, you can calculate this is 2 power 16 hosts. So in a similar way, you can calculate for class C, for class D, and for class E. And for class C, first 24 bits are given for network ID and next 8 bits are given for host ID. And in the first 24 bits, first 3 bits are fixed, and then rest you can calculate what is the range for the class C. So if you see there are only 8 bits that are given for the host ID, which means that 2 power 8 is 256 hosts. So same procedure you follow it for class D and for class E, and in the comment section you can provide range for all the class C, class D and class E. So, and here the class B is mainly used for, you know, like big institutions like SBI or IRCTC. So this is all about IP address, guys. So found this video informative, please do like, share and subscribe. Thank you.